Hi there guys, welcome to this video looking at the operations of numerical fractions. We've got two examples we're going to work through here. One where the operation is an addition question and one where the operation is a division question. The other thing to notice with both of our questions is that our fractions are in mixed form, and by that we mean we've got part of the question as a whole number and part of the question as a fraction. So there's a step to begin with both of these questions. We're going to convert these into improper fractions or top-heavy fractions. So let's have a go at this first one here. The question is currently talking about fifths, and we know that there's 5 fifths in a whole one. So if I have a whole one here, that's equivalent to 5 fifths plus the 3 fifths that are already there. So I know that this is equivalent to 8 fifths as a top-heavy fraction. Same on the other side here. We're talking about quarters, and we know that there's 4 quarters in a whole one. So I've got 2 whole ones here, so I've got 4 quarters and another 4 quarters, plus the 1 quarter that's already there in the question, so that gives me a total of 9 quarters. So all I've done is change the form of the way the question looks. I've turned 1 3 fifths into 8 fifths, and I've turned 2 1/4 into 9 quarters. So some steps to follow then when adding fractions. Step 1, the denominators, the bottom number, need to be the same. And to make them the same, the easiest way is we multiply them together. So I'm going to do 5 times 4, which is 20. Now, a little bit of a hint here for you. Our answer is going to be out of 20 as well, because we're adding portions of 20 together. So I put the answer box in now so I don't make a silly mistake later on in the question and forget and add the bottoms to make it out of 40. Step 2 then. What did I do to 5 to make it become 20? Well, I multiplied it by 4. So I need to do the same to the top of the fraction as well, otherwise I'm going to be changing the fraction. So 8 lots of 4 is 32. So 8 over 5 is exactly the same as 32 over 20. They're equivalent to each other, just 4 times bigger. On the other side, 4 to 20 is multiplied by 5, so I need to do the same to the top as well. 9 5s are 45, so these are equivalent fractions. And then step 3, add the tops only. So I've got 32 plus 45, so I've got 77 over 20. It doesn't tell me to simplify this back down, so I could leave it as that and get perfectly all full marks in the exam, but I am going to cancel this one down. So we're talking about 20ths, which means that 20 pieces within here make a whole one. So if I count up in 20s, I've got 20, 40, 60, 80 takes me too far. So I've got 1, 2, 3 whole ones, using up 60 of these portions, and that means I've got 17 20ths left. So the answer to this question is 3 and 17 over 20. For division, we're going to start exactly the same way as we did with the addition, and we're going to make these top-heavy fractions. So, talking about fifths, there's 5 in this whole one, 3 that are already there, so I have 8 fifths. Talking about sevenths now, there's 7 sevenths in a whole one, so I've got 2 whole ones here, so that's 2 lots of 7, plus the 1 that's already there, that gives me 15 sevenths, and I'm going to be dividing this by. So remember, divide means how many of this fit into that. There's a simple 3-step method for division, which you won't kind of develop an understanding from, but it's going to allow you to answer this question correctly. And the steps are, number 1, keep the first fraction exactly as it is, so we keep it as 8 fifths. Number 2, flip the second fraction, so I'm going to turn it upside down. I'm going to do what's called a reciprocal. So instead of 15 over 7, I'm going to have 7 over 15. And then because we've flipped this, because we've changed it into its reciprocal, we also, step 3, change the operation. We do the inverse of divide, which is multiply, and then we follow the steps for multiplying fractions, which are really simple. Multiply the numerators, so 8 times 7, and multiply the denominators, so 5 times 15, and there we have our final answer. So how many 2 1/7 fit into 1 3 fifths? Well, not even a whole one, 56 out of 75.